So I want to talk about some of the automation enabling technologies like that that are available. Um, so I guess I'll throw this one out of Barrett since you're on my screen. We'll go to you first. Share some examples of how PAT can serve as a building block or is foundational to future process automation.
Sure. I mean, I think I touched on this a little earlier, but if you basically, let's just talk about control strategy, right? So if you're, you've set your control strategy, and if you have the ability to either monitor in real time or gather a lot more sampling points, of course, that's going to be a building block for when you start adding in those additional automation pieces, right? Because the one thing that I see as a big challenge to any sort of automation in general is process knowledge and expertise. Whether you're taking a product that's already on the market and you're thinking about going continuous with it, it's having that legacy knowledge and that data set that you can obtain from PAT monitoring to understand what potential hurdles you have when you're looking to go continuous.
Mm-hmm. Paul, other thoughts on that? How PAT might serve as a building block or foundational to future process automation?
I mean, I think in the same as our industry kind of builds on challenges of today, turning into successes of tomorrow, turning into the way we do it in the future, I think it's all an ongoing expansive database, whether it be continuous flow or, there's so many examples. The one that I'm kind of curious about going forward, right? We've just done some things in 9 or 12 months that it's taken us 10 or 12 years to do, maybe just 2 or 3 years ago via the pandemic. So I'm just curious to see what that's going to result in our industry. So I suspect that there's some things that'll be done differently. Everybody wants to talk about the work that's been done from an immunology perspective, but I think, what else, right? And there's treatments and there's just science that's developed over the last couple of years that now we need to see what that's going to look like going forward. So for me, less specifically, but more conceptually, it's a lot more about the never-ending evolution of our scientific database and how we continue to build that out.
Mm-hmm. Yeah. So, PAT is not just an investment in the automated future. It offers value even today's more manual environments. I mean, obviously data contributes to the effort, regardless of how automated or continuous you are. So to what degree have you or your clients, in your case, Barrett, leveraged PAT in your current or previous roles, and to what end? Like, recognizing that we're not quite there yet, where have been sort of some of the key points where you've realized the benefits of PAT? Paul, let me start with you.
Yeah, I think for us, so again, we do a lot of work outsourced, at least in the U.S. So that work has been driven largely by our supplier base, but the backside, we've got some internal factory space in Japan, so that's actually gone pretty well. In terms of our ability to better understand the key process parameters and the key, process measurements of the product while we're in process. And obviously you can take, quicker action and more definitive action to adjust those back into either specification or within the desired range. So I think that work, and again, I'm not splitting the atom here. This is pretty straightforward stuff. It's just the application is complicated, because it's not an easy thing to find. So I think the things that you would expect to hear about in terms of how we've leveraged it have allowed for us to do a better job of doing in-process analytical work as opposed to analytical work on a batch that was completed yesterday. By the time we get the data, it's already too late to actually make any adjustments.
Yeah. Take a couple of audience questions. Regarding PAT. Question from Guang Yi. What are the gaps for current PAT technology to cover all the quality requirements and upstream processes? Barrett, where are you seeing gaps?
Let's see. Gaps. As far as upstream, I still don't think they have the abilities with regards to, I consider filtration part of upstream, so maybe I should say that up front. I know that's one of the areas that they still need improvement on, but that as far as getting real-time, continuous filtration. So that's one area that I see as improving, but I think it's lacking still. Other than that, it just really depends on your process and your sampling. We have probes now that can do IgG. We have probes that can do real-time chip-based amino acids. We have probes, obviously for PHDO and all of that. I think it's almost already there. Obviously there, depending on, what you're doing, improvements can be made. But I mean, at least as far as upstream is concerned, I've seen, even working with vendors that have real-time sampling that have feedback loops as well, like, your bioanalyzers that measure offline pH in your metabolites. That's already there. So I think upstream, and again, that we've been, kind of working on this since the 90s, is very close to being fully continuous as far as I'm concerned. I think, as I touched on before, it's the downstream that's where the significant investment needs to be made.